Hello guys, welcome to my channel. In this lesson we're going to learn about complex conjugates and how we can use complex conjugates to help us in the division of complex numbers. Okay, yes, so because in order to divide complex numbers you need to know complex conjugates. So they help you solve problems involving division of complex numbers. All right, let's go ahead and get started. So let's take for example, say a complex number like this. So we're learning about complex conjugates now. Okay, you have a complex number, let's say 2 plus 3i. Okay, so the complex conjugate of 2 plus 3i is done such that the real number remains the same, but then you have to change the sign for the imaginary part. So it'll be negative 3i. So this number here will be the complex conjugate of 2 plus 3i. Okay, so in other words, or in other ways, what I do is if I write 2 plus 3i and put this bar on top, what that means is I'm asking you to write the complex conjugate for 2 plus 3i. Okay, all right, so the complex conjugate for the complex number 2 plus 3i will be 2 minus 3i. So these are the different representations of that. Okay, let's go ahead and see how we can use this fact to solve problems. To use this fact to solve problem, they say that whenever you multiply, uh, a complex number to its conjugate, because in general they use z for complex numbers. So if you multiply any complex number to its conjugate, it always has to give uh, a positive real number, a positive real number. So what I mean is this. For example, if we represent uh, a complex number as a plus bi in standard form, and we multiply that to its conjugate, which will be a minus bi in general. Okay, this is the conjugate, all right, and this is the complex number. So when we multiply them, they say, or we will find out. All right. Okay. Not about what they're saying now. So if you multiply this, if you expand, if you do carry out the expansion, you're going to end up with a squared plus what? B squared. And the imaginary parts will just disappear automatically. So let me show that to you. So we will multiply a times a, and that will be a squared. And we'll do a times negative bi, it will be negative abi. And then we'll distribute this way as well. So there will be abi positive, abi. And then we will multiply these and it will give us negative b squared and I squared. Well, there's an I here and I there, two I's. So when they multiply, you get what? I to the squared. Again, we're going to keep this result because it is a real number. And then notice how these two parts just zero themselves out because they're opposites of each other. So I'm going to be left with negative b to the squared. And I know that I to the second power is negative 1 again. So in our previous lessons, we have been showing all of these things. So it'll be minus 1. So now from here, when you multiply, you will see you have a squared plus b squared. So this is how they know that. So I just wanted to show this to you. So every time you multiply a complex number to its conjugate, you always end up with a positive real number. All right, that's good. So bearing that in mind, we will now try to see if you understand this by asking you what will be the complex conjugate to maybe like 4 minus uh, say 5i. Okay, so what will be the complex conjugate to that? You say, okay, the complex conjugate to that will be keep the real part and do the opposite of the imaginary part. So this will be the complex conjugate. Okay. All right. And let me test you again. Like, hey, if they say what is going to be the complex conjugate to, let's say, 2i plus 3. Okay, so I know a lot of students would say the complex conjugate will be, they will say 2 minus 3. But then this is not how you write complex conjugate. So to write complex conjugate is not just about changing the sign or changing the sign here to negative, okay? Or changing negative to positive. No. So the idea is for you to keep an eye on the imaginary part. So you have the imaginary part is actually 2i. So which means this expression here can be rewritten as 3 plus 2i. So once you have it written this way, you would now see that the complex conjugate will not be 2i minus 3. It will be what? 3 minus 2i. So this will be the complex conjugate to what you had here. Okay, so I just wanted you to be very careful about how you are looking for your complex conjugates. All right, so we are now going to use this idea to solve problems. Okay, so let's go ahead and get started with the first problem here that wants us to simplify. They say simplify. First one wants you to simplify 3 divided by 3 minus I. To simplify this problem here, you do not want imaginary numbers in the denominator. So because of that, you would use the complex conjugate to solve the problem. Okay, so the complex conjugate of this 3 minus I will be 3 plus I. So, and then we're going to multiply the denominator and the numerator by the complex conjugate. So I'll just extend this division sign. I'm just going to throw in my 3 minus I and wrap it up with parentheses and do my 3 over there. Now I'm going to multiply the denominator and the numerator by the complex conjugate. And this is how I'll be able to remove the imaginary numbers from the denominator. So make sure you keep the quotient equivalent. All right, so this is what I have. So from here, I will start from the numerator, which is going to be 3 times 3, 9. 3 times I, that's 3i, and I'm going to divide it by, okay, so this is what you're saying here. So from this result here, I don't know if you can still see that, okay, they say that when you multiply complex conjugates, you end up with real parts, positive real numbers. So that means I'll just do 3 squared, okay, that's a shortcut, all right, so then I know this is 1i and another 1i. So because the coefficient of I is 1, it will just be 1 to the squared. See, this is like a shortcut to me. So which is very good, very good. So 9 plus 3i over 3 squared is 9. 1 squared is 1 times 1, which is 1. Okay, and that's going to give us 9 plus 3i divided by 10. All right, so this is the quotient form, but not yet in standard form. So what I want to do to separate the real parts from the imaginary parts, so I'm going to need to cut my division sign in half and keep 9 over 10, then plus, and I'll do 3i, and keep that with what? 10. So which means my final result is actually looking like 9 over 10 plus 3/10 of what? I. So this is now in standard form. But if I stop here, I am close, but I'm not close enough to the final. Okay, so the final is to be able to write your results in standard form. Let's go ahead and try another one. Okay, let's take a problem like, say, number 2, which wants you to simplify. Okay, so simplify 4 plus I over 3 minus 2i. So again, for this problem here, I just need to find the complex conjugate to 3 minus 2i. So the conjugate will be 3 plus 2i. All right, so I am now going to multiply the numerator and the denominator by these conjugate. So I have 4 plus I have 3 minus 2i. And I'm going to multiply by the complex conjugate. So which is going to be 3 plus 2i, and I have to do the same to the numerator, 3 plus 2i. All right, to finish it off, I know that the denominator is going to become very simple because I have 3 and 3. that just gives 3 squared. So I then have to do addition plus, always, 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 because this is the formula. Okay, so every time you multiply complex conjugates, you end up with positive real numbers. Okay, so that's why I'm going to do 3 times 3, which is 3 squared. Then I just ignore the negative sign, whatever that is. Then it will be 2 times 2, which is 2 squared. This is the magic. Okay, now to the numerator, I just need to make sure that I do my distributive, use my distributive property. 4 times 3 is 12. Then I do 4 again. 4 times 2i is going to be 8i. Then I'm going to do I times 3, which will be positive 3i. And I'm going to do I times 2i, and that's going to be positive 2i to the squared. All right, let's moving together. I have 12. Just copy this 12, and then make sure you combine these like terms, which is going to be 11i. And then I'm going to do plus 2, and I to the second power, we know that that's negative 1, right? And then we're going to divide that by 3 squared means 3 times 3, which is 9. And 9 plus 4 will be 13. 13. All right, so let's keep going. So from here, I can combine 12 and negative 2, because this is negative 2 right here, right? So 12 minus 2, that's going to be 10, right? So that will be 10. And then I'll just add my 11i, and then I'm going to divide by 13. All right, so now I need to separate this to keep it in standard form. It'll be 10 by 13 plus 11 over 13i. And this will be your final result. There are more. I hope this is helpful, and I want to see you come back here next time to learn more. Thank you for subscribing to my channel, and I'll see you again.